Welcome to Haxby Shed. Now if you follow my channel, you probably already know that the tapered pin that goes into my vertical milling head here, that indexes it to 90 degrees, is bent, and I need to make another. Somebody's already had a go at it, you know, they've ground around here, but it's not working properly because when I put the pin in, the head isn't vertical, it's off by about 1/3 of a degree. So I've tried to measure this. I think it's 1.5 degrees internal angle. Now it doesn't seem to fit with any standard taper pins, which I think are 1:50 for metric and 1:48 for imperial. This is about a 1:76, I think. Now making a new pin involves cutting a very accurate angle on the lathe, on the top slide, or compound slide if you like to call it that. And I'm going to show you a technique to do that. Now this technique is not unique at all. It's been shown many times on many YouTube videos, but if you haven't seen one of those, you might benefit from seeing this. So let's go over to the lathe and I'll show you. We're going to set this up by measuring the change in distance between the top slide and the tailstock quill as we move the top slide across. Now I can get 75 millimeters of travel on my top slide, so near enough 3 inches. We know what angle we want, which is 0.75 degrees, which is half of the internal angle of that pin. And it's quite easy to work out what this distance X is here, question mark. That distance, 75 times sine of the angle. And so this distance here is 0.9817 millimeters, nearly 40 thou, 39 thou, something like that. So the first check we need to do is to make sure that the quill on the tailstock is actually parallel to the bed. So I've extended the quill about 3.5, 4 inches, something like that. I've locked it. I've set my gauge to 0. I'm going to move the carriage along, and I'd hope that stays at about 0, which it about does. So that tells me that that quill is parallel to the bed. So we're off to a good start. Actually, that's the first time I've done that and I'm quite surprised. It's better than I thought it might be. I'm setting up this taper so that it's angled this way. So the distance is reducing as I move towards the headstock. And the first thing I've done is to wind back the top slide as far as I can this way. And then I've taken out the backlash and I've set that to 0. I've moved the cross slide in to set the gauge to 0. I've set my cross slide dial to 0, so everything's zeroed. If I move this across 75 millimeters, if this is set correctly, then we will move about 98/100ths of a millimeter. We'll see that on that gauge. We'll also be able to check it on this cross slide dial. So here goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Something, 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 because I know where it stops actually. So I need to move this on 75.5. And it's nearly right. Hold on. Actually, I'm going to repeat that because I didn't lock the saddle. Carriage, I called it earlier, didn't I? Same thing. Check all my dials are still on 0. I'm moving this top slide across 75 millimeters, and when I first started, I did it by counting the turns. Each turn is 2 millimeters, so that's 37.5 turns. But I've done this so many times now, I know where the end is. So we'll just whiz this along. It's very difficult to get this set within 1/100th of a millimeter. The results are not completely repeatable, even if you take out the backlash. We'll see how close we get this time. I'm probably going to leave it at this, to be honest. It'll be about there, so if I move that to 1 millimeter on that dial, look at that, 98/100ths of a millimeter. Spot on this time. Because we're setting up a fairly shallow angle, it's very easy to read straight off this dial. But if the angle was greater, we could easily lose track on this dial, but we can double check it on the top slide dial. And just as a check, I can wind this until this goes back to 0 and read it off here. And it's reading just under 1mm. I would say that is about 99 100ths. So there's an error of 100th of a millimetre. But I think that's still pretty good. And I'm going to try cutting the taper now and see if my 1.5 degrees is right, because I could only roughly estimate that because the pin is, being ground up and it's quite worn. My test piece is a piece of wood. Putting the peg into here feels right. That's a nice tight fit, there's no rock on it at all. I think we might be right with the 1.5 degrees, but when I try this, I get a rock. It pulls forward a little bit more than I would like, but even so, I can feel a bit of rock on it there. Now it may be that this has swollen a bit at this end. Yeah, there might even be a slight lip on here. It does look as if it might have been hit once or twice, I don't know. So I will countersink just this front edge of this. But I've just about enough confidence to have a go at this in a piece of metal. This material's really soft, and that went in a bit further than I really wanted. Never mind. Even this original pin has some rock on it in this bush. And when I look inside the bush, I can see stripes where it's only touching, periodically. So I think my pin's probably okay. That's not bad. So just threading this 3/8 UNC, try and get it something like straight. This is only mild steel, so we can't expect much from it. New pin, old pin. I get about the same effect in the bush. Just a little bit of rock on it. Actually quite a lot of rock on it, to be honest. But I don't get any rock at all when I put it into the head. Well, we're still not there with this. We've got a nice new pin. Push it in, look where it comes to, but that's without the bush. Put it into the bush. Push it in, look. And look where it comes to. It doesn't even emerge, and I can see daylight round it. So I always imagined that those would be reamed together with a 1.5 degree reamer. Evidently not. So the problem, I think, is this bush. Don't know what I'm going to do about that. Have to think about it. This job is a total pain. I thought, simple, just make a new peg, great. Now you've seen all the problems, but actually it's worse, because when I check this bush, well, we know the taper's not right in it, but it's also not square front to back, and the hole's not in the centre. Now you would have hoped that what they'd done is put the bush in and then they'd line reamed it through from front to back through the bush, but we know they didn't do that because you've seen the problems. So probably the right way to do it is to make a tapered reamer, but I've got a problem with that. It's a lot of work. I don't have the tooling to make the flutes on a tapered reamer. I can make the basic shape, that's easy in the lathe. I could make a D-reamer, but the D-reamer needs to be hollow ground or hollow machined. I probably could do that, but it's a lot of work. And then this is my piece of silver steel. It would only come out to about here. I can't get the drill chuck on it for the hand drill, pistol drill. So I need an extension on it. With an extension, that means putting a hex on it probably. It's all just too much work. So what I'm going to try and do, because this bush is a heap of junk anyway, I'm going to bore that exactly by dead reckoning. Now I worked out that my pin needs to travel in another 7mm, and we know what the slope is. So the slope is 0.98mm in 75. So a bit of working that backwards. I'd have to machine off the radius 0.091mm off the inside of this bush. And I think I worked out that was about 6 thou on the diameter, something like that. So it's only a very small amount, but I don't think I've got anything to lose, so that's what I'm going to try. I'm holding this by hand. Look at it. What are you supposed to do with that? We can use this wooden peg as a guide. So I've put a line on there where that peg comes to the face, and then another line here which is 7mm further to the right, and when I've machined out so that that line on the right is against this face, that'll be my 7mm. Now it might seem a bit crude, but I think it's an appropriate level of accuracy for what we're trying to deal with. Anything short of making a reamer, you know, is going to be a compromise, but it's sure going to be a lot better than it was. I've ground up a tool out of a piece of 1/4 inch high-speed steel, and I've just touched off. I can see my cutting line. I'm just taking it easy. It seems to be an even cut. Do you know, it's almost there, isn't it? Hold on. Did I get that right? No. Halfway there. That's about what I expected. I've put about 0.06 cut, and we need about, what did we say? 0.09. So we're 2/3 of the way there, and that looks, yeah, that looks right. Good. Now, like I said, all of this has been done by dead reckoning. But if I put that in there, you can see that line lines up with this face. And I've also got a second confidence test, because this is my new pin, and I know where this should fit within this bush, give or take. And you can see the blue on there. Well, I blued that up, and I put it into the taper on the back of the mill head, and it scraped it quite evenly. So I'm quite happy that it is actually a 1.5 degree taper, or so close as to make no difference. This pin should nearly go through, but not quite. There you are. I can't push that any further. I think that is as close as I'm ever going to get this. So lining the bush up with this hole corresponding to this grub screw, and then the peg, I think that is going to do. I can't get any movement on the back. Maybe a little bit under what I need. Looks right though. So I think I'll leave that there. The next thing is to make a new peg, because this one needs to be a larger diameter, because obviously it goes through too far. next step then. I'm making another pin in a slightly bigger diameter using a stainless alloy. Hopefully it will give me a better finish. So I've roughed out some of it here, but I've just gone back to cut the thread before I finish it. Using a bit of the coolant to lubricate the thread as I cut it. And this device on the tailstock keeps it all true, which is useful. So with the new peg, now just earlier I had this bush loose, tapped it in like that. The peg seemed to stick as much in the front as it did at the back, so I think I've got it about right. At the moment I've not loosened off this head, I've got it clocked at vertical. If I take the peg out, loosen these off, swivel it back, put the peg in, it should bring me back to vertical. If it doesn't, it can only be that they put the hole in the wrong place. Now all along I've assumed the hole's in the right place. To get out of that problem, I can make another bush with the hole in the right place. By measurement I could figure it out. I ain't going to bother with that today. I think I'll probably stop at that. These things never go smoothly when you're trying to demonstrate, do they? So I will now set this to a random angle. Right, and we'll now put the pin back in. Okay. We will now clamp it up. I hope you're on the edge of your seats. We will now embarrass ourselves by looking at whether this is on zero. Oh my goodness, it's on zero. I'll show you. So you can see the scale on here. You can see the zero. You can see that very fine line. As far as I can tell, that line and that line are lined up. Now it might be a few thou out of vertical. We'll have a look at that in a second. But that was showing about 1/3 of a degree displacement previously with the old bent peg. So we've achieved something. Well, with the pin in, I need to check how vertical that head is. So it needs to be trammed, and we need to find a way of measuring. Now I've watched a number of videos, and people we may know have used things like a cylinder square and tested them against the quill. Well, this doesn't have a quill. Here I've got a Clarkson collet holder, which I'm trusting to be square with the spindle. And also I've seen people using fancy things with a T on it and then a couple of dials and all that stuff. But it occurred to me, you know, with a magnetic base, I could just hang it off here, measure it this side, swing it round, measure it the other side, and then I'll know where it is. And that seems to be working. It seems like quite a good method. Now, I have actually trammed this head and it is vertical. The pin didn't quite get it vertical. What I was finding was between here and here, when I swing it round, that's about 460 millimeters, and the difference was about 0.4 of a millimeter just by locating it on the pin. Now I worked that out as an angle. It's a bit irrelevant, but I did, and it was 0.05 degrees. 0.4 of a millimeter, I should say, is about 16 thou. Well, you might think that's near enough, and it probably would be near enough for most things that you'd be doing, but it wouldn't be near enough for something like this. That's 100 millimeters across, 4 inches. And if we were machining a block, well, it doesn't matter what we're machining. What we're interested in actually is that distance, half of this, which is 50 millimeters, 2 inches. And so by proportion, if we've got 16 thou between like here and here, that's going to be, well, I don't know, 2 thou, something like that. Well, 2 thou is too much. So just locating on the pin is close, but it's not perfect. Making a new pin and machining that bush, it's a darn sight better than it was. It's pretty good, but it's not absolutely right. So I've managed to get it, I've managed to get it within about a thou, 2/100ths of a millimetre. And the way I do that is simply, let me walk round, is simply take a reading this side, lift the plunger, move it round, take a reading this side, and when I check it, it's within 2/100ths of a millimetre. I'll show you that now. So here's at one side, we're on 0. We're struggling a bit with the accuracy of the gauge. I mean, if I tap it, it might not return exactly to 0. So, you know, we're getting near the limits of what we can measure. But if I then just lift the plunger, swing it round to the other side, check that measurement, and that's our tram. Well, yesterday it was measuring 2/100ths, now it's measuring 3/100ths. But I've tried several times to get this spot on, and it is very difficult, so I'm going to leave it at that. Now we've trammed the head to be perfectly vertical, we're slightly away from the position which would be set by just bashing in the taper pin. But the error is so small, I think I said 5/100ths of a degree, and for nearly all the jobs we want to do, just popping the pin in would be perfectly fine. So it's a lot better than it was, and I don't plan to do anything else with it. What are you doing that for? You look back on this and wonder why you did that.